So in any software development um, work, the final stage, once we have designed the system, you have to implement it. So in today's one, we first going to look at system implementation. So under the system implementation part, up to that point, we are going to actually make all the design part. So last session also, I actually revisit, for example, the modeling tools for database design, where we talk about ER to logical and then logical to physical models and so on. So that's the design part of it. So once you actually finish that part, we'll come to the implementation part, which means we have to implement the system using, appropriate architecture, choosing the appropriate architecture, which you have discussed with the Yasara. And then you have to also select appropriate what you call the programming language, and then you develop it. So when you develop, you know that you have to test it, document it. So those are the things that we are going to discuss under system implementation part. So the outcome of this is what we normally call the functioning system. That means you have a software. And then next we are going to talk about the maintenance issue. So that means once you deploy the systems and you are going to work on it, how do you handle the bugs that you are going to get once you implement the system? Right. So in traditional software development lifecycle, we usually see the implementation design. So when you talk about system implementation, we are going to talk about application development. Yes, there was a question on notes. Yes, today I'm going to upload all my notes in the LMS. So the system implementation, during that, we are going to focus on the application development. While you are doing the application development, we have to focus on the testing as well as documenting. Because while you are developing, you have to make sure that your software is working and bug-free and so on. And then you have to develop different types of documentation. You have to provide documentation for the developers, like putting comments in your code. At the same time, you have to test the code, right? And once you finish that, you have to, have some training sessions for those who are going to use your system. Any data conversions, like for example, if you build a new system and if you have a manual system, you have to, make it digital. Or if it is in some old, database to maybe a new database, maybe you have to change the formatting from old one to new one, right? And then you are going to, switch from old system to new system, which we call the system changeover. Right. And at the end of the phase, usually what you have is a functioning information system. Right. So this is graphically shown here. So in the implementation part, you have overall planning, and during the development, you have to focus on design different modules, the code modules, test modules, and the document modules. Usually this is the development part. Once you finish this development part, we have to perform various different type of testing, which I will discuss using Python. Very small example, which you can actually practice later on. So starting from unit testing, we can work on, that means unit testing means each individual module you can test. But then again, you have to test multiple modules, how they interact each other. This is called integration testing. Once you finish that, then you have to test everything together. We call system testing, and you will go for the documentation part, right? So if you look at how we could develop this, we need to use some system development tools. For example, if you look at traditional structured development. There you might already have done like modeling tools like data flow diagrams. So in data flow diagrams, for example, we will see data transfer among different entities. So that is one way to see how data actually transfer between different entities. And then you can also use structure charts for the structured development. Then in object-oriented methods, we have to use variety of diagrams. I hope you have already done use cases, class diagrams, sequence diagrams, transition diagrams. All these comes under object-oriented methods. Then the newest trend towards agile, and it uses iterative fashion. You develop select set of features, then you implement, and then you are going to keep on continuing doing this. Right. So system developers use generic tool to translate the logic into functioning program modules. So for example, things that we could talk about under this are like ER diagrams, flowcharts, pseudocodes. Even we can use decision tables where when you want to make some business decisions on the products you can use, and even the decision rules. Right. Now that we have looked at this, let's focus on the testing part of the system. Now, usually programmers are the ones who actually implement in the code, and they can review the code, go through it, and then individually they can test their functions. Now, for example, let's say you create a set of functions in a module. Then if you are going to test each of these functions, then that will be the unit test, right? So that means using that, we can talk about evaluating this by writing some test cases, which I will show you in the next slide. So the testing part, then we can include these set of functions, for example, and then you can see how they interact with each other, which we call the integration testing. And finally, you test the whole system, right? And during this time, usually you will include the users who are going to use your system. For example, let's say you build a system for a school, then maybe school principal will be there when the testing happens. Right. Again, graphical representation. In the graphical representations, here we can see like how different tests are performed in graphical manner. For example, if you, let's say you have 6 different programs. So one way is you test each of these programs separately, and this is called unit testing. But then again, if let's say the programs are interacting each other, so how they actually interact each other can be determined using integration testing. Then finally, you can test everything together, which we call system test. Right. Okay. There are many software testing strategies are there. There are specific tools and cases are already there, but let me give you some basic understanding of very basic, test cases. And nowadays, these testing is normally automated. So therefore, if you automate this testing process, we don't have to do manual testing. And at the same time, you can apply for various different, testing strategies, like starting from unit testing to integration testing and system testing. Right. Now let's look at automated software testing, which is quite popular nowadays. In this part, I would like to show you like two ways you can actually test. You can look at the test and then the different ways of testing this, right? Automating testing, therefore, you can use in various ways. For example, the testing example could be included in the code itself, which we are going to see now, right? And then you can use that into tests. For example, in Python, which I'm going to show you some examples, where we can include your test data as a part of the code, right? So let me start with a small example. So I'm going to use two tools to describe you how you can perform testing in Python, right? Since you have already know Python, let me explain how Python is used for test automation, right? My first example is about testing a function. So I hope you remember the code. In this simple function is called add numbers, and we are getting two arguments. We define as n1 and n2. Simply what it does, it will return the addition. Now, that's simply how you write the function. But when you want to make the code as a documentation, as a test, in Python, we can use it as a PyDoc and PyTest, right? What do you mean by PyDoc is simply you can include everything inside the code. So these three double quotes indicate the start and end of the PyDoc, and that means documentation in Python. And here you can see that this information is there, right? And these are what we call the examples. We can make use of these examples. And for example, so these are, we can think as a test cases. If you provide two integer values, 34 and 67, we expect this as the outcome. Similar to this, if you provide like two numbers with decimal points, then this is what you will get, right? So let me demonstrate that briefly, and then you can actually try this at home. So to do that, I will take a small part of the code. So as you can see, what I'm going to do is, right, I'm going to share my screen. Okay. And then I'm going to get a Python idling one. So I hope that you are very familiar with this one. Right. Now what I'm going to do, I'm going to get a new window so that, okay, I will have this. So this is the shell and this is the new window. I'm going to get it as half and half in the screen. So let me take it as a half of the screen, and the remaining half I'm going to have the other part. So what I'm going to do right now is I'm going to write a simple function. So this simple function we have already seen is adding two numbers, right? So I will say that, okay, def add, we can say simply def right. So we'll say, okay, what has happened? Right. Okay, so I have disabled my touchpad. Sorry about that. Hope now it will not give you a problem. Right. Okay, so I will type simple function. This is called defining a function, and I will use it as add numbers, right? N1, N2. And simply what I'm doing this is I'm returning the addition of the two numbers. So that's simply what we do, right? So let me save this. Let me save this under the desktop. Let's go to under the DAIT codes. I will say my test. Right. So I'm going to save it as my test, right? Right. Let me run this. If you run this, okay, without running, let me show you first. Now, if you open up your right shell, and if you try to use this function, this is a custom made function, let's say 10, 20. It is not recognized yet because we have not, run this. So let me run this. If you run this, you can notice that, okay, it's we already ran. Now you can use that. So if I use the same function call again, you will notice that, okay, so it should be at numbers. Sorry about that. So it should be at numbers. And then, yeah, you get the answer. Right. So similar to that, if you say add numbers, let's say 2.5 to 3.5, and then, sorry, again, add numbers, if you use that, yes, we are getting 6.0. Right. Now, this is just how you may use a function. Now, if you want to get a help in Python, you can just type help Python, and this is what you will get. Help will say add numbers. This is my function, and simply just give you a very brief, help document here. Okay, so the next step is, let's discuss how we can improve this. In Python documentation, what you can do is you can include 3 triple quotes, 3 triple quotes, which serves as a documentation string. We call doc string. So for example, I can have something like, okay, the function adds 2 numbers, right? And you can say, okay, arguments, we are getting 2 numbers, N1 and N2, and we can say it returns, N1 plus N2. Okay, what adds to this is, let me run again, and let me discuss the new thing. For example, if you rerun this time you will notice that the documentation is improved. So earlier you have just add numbers in 1 and 2. Now whatever we have entered here will be displayed here, which is helpful for the user. So that means you have improved the documentation for the user, right? Okay, not only that, you can also include, some test cases as well. For example, in our case, we are trying to use 2 test cases. If you look at the code, right, let me try to use the same code as in the node. So we are trying to have, we are trying to add 34 and 67. Yes. So that means let's add numbers 34, 67. And ideally we are getting 101. Similar to that, add numbers. If you say 2.3, 3.5, then we'll get 5.8. So these are like some test cases, right? We put already known values and we are checking whether we are receiving the actual outcome. And this is the case. So we can include this as a part of the code. So what you could do is, actually you can put this inside here, right? This will be inside here, so that now you have improved your documentation. So for example, this time if I rerun, and if you just say help, right? This is what you have noticed. And this is the kind of output you normally see in Python libraries. Okay, next one. Okay, how do you test this? We call PyTest. So what happens in PyTest, for example, we are going to include there's a module called doctest, and then you have to say doctest.testmod. So I'm going to use that information. So I'm going to say that, okay, I will get this. Right, this is what I have. So let me share. Okay, I will say, okay, import doctest. Right. This is we use to test all a defined function, and we will say, okay, doctest.testmod. And what happens if you just type this one, it will go through this and it will try to execute these values and just try to see whether you are getting the correct answer. So when you perform doc test, you get an outcome like this. It says there's no failures. You have tried 2 commands. Okay. So now how do you make sure that this is correct? Let's say when you are developing the code, we make a mistake. Instead of +1 and +2, let's say we put minus, which is, sorry, not here. Not here. Let's say instead of adding the numbers, we subtract. Let's say we make a terrible mistake. So now let's see how this works. So I can use run module. And if you perform the test again, right, with these 2 test cases, you will notice that, okay, it says we are trying to add 2.3, 3.5, right? And expected 5.8, but we are getting minus 1.2. Similar to previously, it says we have 34 and 67. We expected 101. That's the answer we have given here. But what we got is 37. So it says that, okay, there's a failure, the code that you have developed. So very important when it comes to use of PyDoc and PyTest. Right. So similar to this, there are other ways as well. Again, there's another way that we can actually do. It's called PyTest. So it's a separate testing framework which uses with Python. So for example, if you want to test the function add numbers, so in PyTest, you have to slightly modify this. For example, you have to create a separate file called test add numbers, and then you can actually perform this. And here's the difference. Here we have a new keyword called assert, and then you call that numbers with the values, and you will list the desired outcome, right? So in that way, we can also get information. For example, this is a sample run. If you do type in my PyTest, it will check, and it will check a particular Python file, and it says that it passed. Right. I hope you got some basic understanding of how the testing will happen, and we had a in-depth treatment for a function which adds 2 numbers. Right. Now, having said that, the next part would be we have to talk about various types of documentation. Now, for example, one type is called program documentation, which we can use to describe the input, output, and processing logic for the modules. Second, you can have a system documentation, which will describe the system functions, how they are implemented. And then this documentation, you have data dictionary entries, data flow diagrams, object models, screen layouts, source documents, and system requests that initiate the project. Right. Last two is operations document. That means those who are going to work with the system to work, let's say a software, you have to have instructions. Similar to the last one is for user documentation, which means for a general user, we have to provide how to interact with the system. So that's what comes under the user documentation. Right. Next, usually once you do the development, you need to install the system and you need to evaluate. So usually when you set up the implementation, you should not touch on your working system, which we call the operational system, but instead we should test in a test environment. Right. Right. Test environment, operational environment means, and now usually when we have a system installed, let's say a site like Amazon. So you see millions of users are accessing this information, which will be very huge. But if you want to test something, right, you should not try with the operational environment, which means you should try with the test environment first. And if you are satisfied, then you can authorize the changes. The training part, as we have discussed, there are like several, training happens. And then here, what we discuss is for the people, we have to use appropriate training sessions. Right. Okay. So here are like some of the training things that we can discuss. There'll be users, the managers, the IT staff. So you can have various different topics when they are on training. Okay, data conversion, I told you, like depend on whether you are going from manual to digital and so on, you have to use that. So we can do data conversions. You can do it before, during, and after operation environment is complete. So what happens during this? You replace a new system with the existing system, and you also should be able to automate the data conversion process. Right. Now, next topic is, once we have the system, how do you deploy? Deploy means you go to the place where you want to install the system. So for example, the library management system that we have discussed is for the library. So how do you, change this? Right? That's where we are going to discuss. So there could be multiple ways actually, you terminate your old system and then you move to the new system. The first one we call direct cutover, which means you completely abandon the old system and then you start working with the new system. And the second one is parallel, means you go hand by hand. That means you operate in both old and new systems. Pilot operations, which means you select the specific group with the organization, which you can use for new system for the period of time. Right. So that means you can actually use what we call all the available system That means old one will be available for some of the users. Final one, phase operation, again commonly used technique, which means you implement the system for an entire organization, but one module at a time, for example. So that is what we call phased operation. So this is what you can see in graphically, which I'm not going to explain, but I think it's direct how you go from old to new system. Similar to that, you will also notice here, right, that how the costs and also the risk is handled. So for example, the cost will be low for the direct cutover, but the risk is very high. So pilot operation, on the other hand, costs a bit of more than this, but then it will be around this. Then phase operation also the same. Parallel operation, you have cost will be very, very high, but then risk is very, very low. That's what this graph shows to you. Right. Now that we have implemented, we have to look for post-implementation evaluation, which means once you finish the sale, for example, you have to evaluate. So check for the accuracy, completeness, and timeliness of the information, user satisfaction, system reliability and maintainability, adequacy of system controls and security measures, hardware efficiency and platform performance, effectiveness of database administration, performance of the IT, completeness and quality documentation, quality and effectiveness training, and accuracy of cost benefit analysis estimates and development schedules. Right. And finally, once you finish that, you generate is a report which includes about the final system. And also you can briefly explain like what will be their further system enhancement. Okay. So with that said, we came to the last part of the presentation, which means once you develop the system, implement it, you hand over it, and then you need to provide support. Why? Because system can come up with various different issues, right? So you have to support once you actually sell something, you have to support the system, and you have to think about any security issues, integrity of the system and data, right? So once you finish that, what you're getting is operation system. But then in this graph, we can see how the costs are compared. For example, operational costs is almost the same, but then maintenance expenses is slightly varying. Right. The next one is different types of maintenance. Now, when we talk about the maintenance, we can talk about 4 types of maintenance tasks. Corrective means you fix errors. Adaptive means you are going to add new capability or enhancement. And then perfective maintenance, if you want to improve the efficiency part of it. And if you want to avoid, you can reduce the possibility of future system failures. Right. That's all what I have you to discuss with you. Then there were a couple of questions I can see. Let me stop my recording.